All right, so section 12.6 is where we left off, which we simplified, multiplied, and divided. Today we're going to add and subtract. Rational expressions. Adding and subtract rational expressions. Okay, so adding and subtracting fractions. What was that? What was that? I mean, I want you to take notes like you're in class, man. I've been doing this since August. Adding and subtracting rational expressions. Okay, so we're adding and subtracting fractions. What's the rule for when you add and subtract fractions? You got to have the same denominator. If we don't have that, then we can't add and subtract yet. So some of these that you're going to have, like this first one, already have the same denominator. If they already have the same denominator, those are the easy ones. You just add the numerators together. So 5 plus 7, those are like terms, so that'd be 12. And then you try to simplify, if at all possible. Okay, so 3 goes into itself, 3 goes into 12, so that simplifies to be 4 over x. Both of those numbers are divisible by 3, so you divide them by 3. So that's the simplifying part that we did back before the end of course test. So we're going to get a little review as we go here. Do those have the same denominator? Yes, already got the same denominator. So that means we can add the like terms that are in the numerator. So what goes together in the numerator? 3x and x. So 3x plus x would be 4x plus 4 over x minus 1. Now, if I'm going to try to simplify that, what do I need to do to the numerator? Take out a 4 with factoring. It almost simplifies, but x plus 4 and x minus, or x plus 1 and x minus 1 are not exactly the same, so you can't cancel anything. So I would take this answer or this answer. They're the same. I mean, the factored form or the not factored form. You always want to try to factor it to simplify. It might not always simplify, but you want to try to do that to see if it will. Okay. Let's do another one. 4x plus 1 over 2x minus 1 minus 2x plus 2, over 2x minus 1. So subtraction problem. So I've got the same denominator, so I can go ahead and do the numerator stuff. So I'm taking the 4x minus 2x. What's 4x minus 2x? 2x. What's 1 minus 2? Negative 1. So we end up with 2x minus 1 over 2x minus 1, which is 1. They cancel each other out, so it turns into a 1. So the final answer is 1. So big ugly problem to start off with, simplified to be 1 by addition, subtraction, and then simplifying. So if the denominator is already the same, you're just going to put the like terms together using whatever operations between them. If it's addition or subtraction, you just do that. Okay. So when the denominator is the same, there's not a whole lot of hard work to do. Okay. And always try to simplify at the end, the same way you would with regular number fractions. You always try to write that in the lowest terms, right? So we would never leave an answer 6 over 12. We'd always reduce it to 1/2. So we want to do that with these fractions as well, to reduce them as far as we can. Okay, so let's look at a few that, well, let's do one more that's the same denominator before we get into the crazy of not the same denominator. X squared over x plus 5 minus 25 over x plus 5. Denominator's already the same, so we try to put together the numerator parts that are like terms. There's no like terms, so I'm just going to write the numerator x squared minus 25. Then I'm going to try to simplify. What do we know about the numerator? It's a difference of squares. That means it factors as what? Yeah. What cancels? X plus 5 cancels x plus 5. That's the simplifying that we did a week and a half ago. So that just leaves us x minus 5 as the final answer there. So there's one that simplifies a little bit. It won't always simplify, but you want a factor to try to get them to. All right. Let's look at one, this first one that doesn't have the same denominator. Okay. We're not going to get too crazy with this and make it just incredibly hard, but the idea here is we need to get the same denominator on each fraction to add them together. Okay, so the first one has 5x, the second one has 10x. Do those have anything in common? 5 goes into itself, 5 goes into 10, and they both have an x. So the common denominator would be 10x. How do I turn this into a 10x? I multiply it by 2. So if I multiply the bottom part by 2, I got to do the top part all by 2. Okay, so that's going to give me 8x plus 2 over 10x. The second fraction doesn't need anything done to it. It's already got 10x there, so I'm not going to change it. I'm just going to leave it x plus 3 over 10x. Okay, so I distributed the 2 to both terms there. 2 times 4 is 8x. 2 times 1 is 2. So that's just what I'm doing there, getting the common denominator. Once it's the same, I can add the like terms in the numerator. So 9x plus 5. Did 9x and 5 have anything in common? No. No factoring can happen, so that means no simplifying can happen. If no factoring can happen, no simplifying can happen. We're left with that. So that's not incredibly terrible. I mean, not a whole lot of hard work there. They're going to get a little bit more difficult than that, but not too much. Let's look at example F. 1 over 28x plus x plus 1 over 7x squared. All right. Obviously, the denominators are not the same, but how are they related? 7 and an x. This one has an x. This one has how many x's? 2 of them. So that means this one needs an x. What would turn this one into a 28? Times 4. So I need to multiply the first one times x and the second one times 4 to get the same denominator on each one. So that's going to be x over 28x squared plus 4x plus 4 over 28x squared. So I'm trying, my work that I have to do is to get the denominator the same. So we know 7 and 28 are related with the 7. They both have an x. So they need, this one had 2 x's, so I got to go to that. All right. Like terms add together. 5x plus 4, 28x squared. 5x and 4 have anything in common? No. If no factoring can happen, then that means we can't simplify it any. I always look to see if we can. It's not very often that it does, but we've got to look to see if it will. Okay? So don't forget doing that. All right. 10 over 3x minus 7x over x plus 2. I'll go ahead and just put that in parentheses. So here we've got a 3x and an x plus 2. That's two completely different factors. Believe it or not, these are the easier ones because they don't share anything. Even though this one has an x, we treat it like it's a different x because it's 3 times x, not x plus 2. So it's like they're two separate things. This one, what you want to do is take 3x times this. So we multiply it by the other denominator. So if the first one gets the x plus 2, top gets that as well. And then the second one gets the 3x. Like that. And then multiply it out. 10x plus 20. Is there a problem back there? Oh. 3x. I'm not even going to multiply out the bottom part because there's no need. It's not going to help you any to multiply out the bottom part. Top part, that's minus 21x squared. And then that's 3x times x plus 2. And then we're subtracting to get the like terms together, if there are any. Are there any like terms? No, so we're just going to copy down everything for the final answer. We got a negative 21x squared plus 10x plus 20 over 3x x plus 2. Now, I've got to check to see if this will simplify. So I would try to do the x method if at all possible. 20 times 21 would be 420. And add to be 10. There's nothing that does that. I'll go ahead and tell you that that does not simplify. So you're done. When the denominators are completely different, actually I think they're easier because you just multiply times the other denominator every time with those. Abigail, get your stuff, come move up here. That'll solve one problem. All right, let's look at this one. X plus 3 over x plus 1, x minus 2, and then x minus 7 over x plus 1, x plus 5. So these two have a little bit more going on in the denominators. They're not completely different. What do they share? They both have an x plus 1. So the first one has x plus 1 and x minus 2. The second one has x plus 1 and x plus 5. So what do each of them need? They've already got an x plus 1. The first one's got an x minus 2, but it doesn't have what part? An x plus 5. So it needs an x plus 5. So I'm going to multiply the first one by x plus 5. What does the second one need? An x minus 2, because it doesn't have that part. Okay. A little bit more difficult on this one because you got to multiply out x plus 5 times x plus 3 and then x minus 7 times x minus 2. So this is going to be x squared plus 8x plus 15. This one will be x squared minus 9x plus 14. The denominator, x plus 5, x plus 1, x minus 2. X plus 5, x plus 1, x minus 2. The same denominator now. And then we're adding. So once you've multiplied these out, I'm just doing distributed property. X times x is x squared. X times 3 is 3x. 5 times x is 5x. 3x and 5x is this 8x that's in the middle. And then 3 times 5 is 15. Same thing over here. X times x is x squared. Negative 2x, negative 7x. That's negative 9x together. Negative times negative is a positive 14. So that's just multiplying that out. Okay. Put the like terms together. X squared plus x squared is 2x squared minus x plus 29. Or x plus 5, x plus 1, x minus 2. 2 times 29 is 58. And add to be negative 1. There's nothing that multiplies to be a positive 58 and adds to be a negative 1. It can't happen. Because they'd have to be both be negative numbers to add to be, or multiply to be a positive, add to be a negative. And things that multiply to be 58 are 2 and 29, and there's nothing else. 1 and 58. Neither of those will add up to be negative 1. So we've simplified that one by adding those. Made it one fraction. Let's do this one. X plus 4 over x squared plus 3x minus 10 minus x minus 1 over x squared plus 2x minus 8. Okay. Now, what's the difference in this problem and the previous problem with the denominators? Well, they're not factored, right? They're not in factored form. So what I want to try to do is factor the denominators so that I can see what they have in common, because they may have a factor that's the same. They may not, but I think they do. Okay. So how am I going to factor x squared plus 3x minus 10? X method. Negative 10, add to be 3. Be 5 and negative 2. So that's x plus 5, x minus 2. Same method to factor the denominator over here. Multiply be negative 8, add to be 2. Be negative 2 and positive 4. X minus 2, x plus 4. So they share what factor? They both have an x minus 2. Okay. So I'm going to rewrite that so that we can maybe see that a little more clearly. All right. So I have x plus 4 over x plus 5, x minus 2, minus x minus 1. All right. Now, what does the first fraction need? It's got the x minus 2. It's got an x plus 5. It doesn't have that guy, so it's got to have an x plus 4. So the top gets another x plus 4. What does the second fraction need? It's got an x minus 2. It's got an x plus 4. It doesn't have this guy, the x plus 5. Again, got to multiply these numerators out. You're never going to multiply out the denominators for me. Okay, there may be times in another class where you need to. Were you taking a test? Okay. All right. So multiply out the numerators. X plus 4 times x plus 4. And let's get that. That'd be x squared plus 8x plus 16 plus 4, x plus 5, x minus 2, minus, and then I'm multiplying this one out. X times x is x squared plus 4x minus 5. And then we got x plus 4, x plus 5, x minus 2. And then I'm combining like terms by subtraction. So x squared minus x squared is going to be what? Cancels out. 8x minus 4x. 4x. 16 minus negative 5. Plus 21. X plus 4. X plus 5. X minus 2. Do 4 and 21 have anything in common? No, so we're not going to factor that, so we can't simplify. If no factoring happens, no simplifying can happen. Okay. Guys, we're not done. Bell hadn't rung for you to dismiss yet. Last one of the day. We may have to finish this after lunch, and that's okay. What's the first thing that we should have to do here? Try to get the same denominator. But what's wrong with the denominators as is? So they need to be factored. So how does x squared minus 16 factor? Good. And how does x squared plus 7x plus 12 factor? Yeah, x method, multiply to be 12, add to be 7. X plus 4, x plus 3. So what do they share? They share an x plus 4. So that means the first fraction needs what? Yeah. This is not that difficult. The factoring is where it'll catch you. If you don't know how to factor, you're not going to be able to do this. You got to learn to factor. And then the second fraction is this in which part? The x minus 4. And then we just distribute, multiply it out. So that's 5x plus 15 over x plus 3, x plus